So I'm going to be talking about areas of composite shapes in this video, and I'm going to be talking about 3 different methods for finding areas of composite shapes. Those methods are the additive, subtractive, and multiplicative method. You don't really have to remember all these names, but it just gives me an easy way to talk about these ideas. So this will be a good first example here because I can use the additive or the subtractive method to find the area of this shape. Now in the additive method, the idea is that we take our shape and we break it up into smaller shapes and then we add them together. That's why it's called the additive method. So I'm going to break this shape into 3 shapes. I'm going to break it into this shape, which I'll call shape 1, this one, 2, and this one, 3. Now, shape 1 and shape 2 are identical, and shape 3 is a different shape. Now, I'll start with shape 3 here. This length here is 3 meters, and this length here, because that's 3 meters, that length is also 3 meters. So that means that shape 3 is actually just a square. So area equals the square plus, and then what are these shapes here? You might not immediately recognize it, but if you draw it on its side, so I've just taken that one and flipped it this way. The length of this is 6, the length of this is 3, not to scale. And the length here, because these are the same and the whole thing's 6 and that is 3, these must be 1.5 each. This is actually a trapezium. Trapeziums don't have to have both of them on an angle, but one of them's on an angle and one of them's straight up and down. That's a trapezium. So the area is equal to a square plus 2 trapeziums. Now you should already know the formulas for those. So the area of the square is length squared, and the area of the trapezium is half a plus b times h. You might have seen that formula written in a different way. That's the way I'm going to write it. I think that's how it looks on your formula sheet. After this, we just put in our numbers for all of these values. And what I'll get here is 3 squared, which is 9. All of this is going to be 13.5, and I'm left with 22.5 meters squared because I'm finding area. Now that's the additive method. If you're looking at that, you can probably guess what the subtractive method is. Now the subtractive method is just finding a larger shape and then subtracting smaller shapes from it. So with this example, if I'm going to use the subtractive method, I'm going to find the area of this large square and subtract this trapezium from it, minus the 1 trapezium. Alright, and it's just formulas, numbers, solution. It's relatively straightforward. So just be aware while I'm doing this square is not the same as that square, right? This square is our large square. And this trapezium is not the same as that trapezium. This trapezium is this one here, not these ones here. Alright, we've got our numbers in there. 6 squared is 36. I believe this here ends up being 13.5, and that will give us 22.5 meters squared, which is exactly what we'd expect, because if you're using the additive method correctly and the subtractive method correctly, their answers should line up. Now, why would we learn both of these methods? Because depending on the question, sometimes the additive method is better, sometimes the subtractive method is better. So in this example, I can't see a way to use the subtractive method, but it's very easy to see a way to use the additive method. I've got a triangle, I've got a semicircle. If I find the area of both of those and add them together, I'll have the area of the whole shape. Now, of course, you know that the area of a semicircle is pi r squared divided by 2, because you only want half the circle, and you know that the area of a triangle is half base times height. Put our numbers in, we'll have an answer. And there's our final solution. Probably something I just need to draw your attention to. Remember that the area of a circle is pi r squared, and the radius of this circle would not be 10. The radius would only be 5, whereas the base of the triangle is in fact 10. Don't get your radius and your diameter confused. Now in the case of a shape like this, which we call an annulus, I can't see a way to use the additive method. To find this shaded region, I'm going to find the area of the big circle and subtract the area of the small circle. So the way I've written this is area equals big circle minus small circle, and I've called the radius of the big circle r subscript 1, and we're going to square that, and I've called the radius of the small circle R subscript 2. Some teachers like to do something a bit more like this, capital R, small r, but I'm going to stick with my subscripts. So obviously, again, be careful here. The radius of the big circle is half of that, which is 15. And the radius of the small circle is exactly what was pictured. So a bit of a mixture there. And then numbers, answer. All right, looks pretty good. That's the additives and subtractives out of the way. I want to show you something multiplicative. So multiplicative means you find the area of some shape and then you multiply it by some value to get your answer. You might multiply it by a number like 3 or 4 or 5 or 6 if there were 6 shapes present. Or you might multiply it by a fraction if what you're looking at is a fraction of a total shape. And you can see here what we're looking at is a fraction of a total shape. Now I've written that as the area is equal to the circle times the fraction of the circle that we're interested in. Now you might think I've written that backwards, and it feels backwards, but this particular question I'm doing is called the sector of a circle. This is a sector of a circle. And it's generally accepted that when you're doing sectors of a circle, you write your formula in this order. Not that it matters, because it's multiplication and order doesn't matter when it comes to multiplication. So the fraction that we're looking at is there's 360 degrees in a circle, and whatever angle we're given here for our sector, that's what this theta value is, Theta. And now all that's left to do is sub in our numbers, find an answer. Okay, pretty straightforward there. We've put in our numbers, we've gotten an answer here. You might notice that 120 over 360 is just 1 over 3 when you simplify it. No real need to simplify it though, because we're heading towards a decimal answer. Now, of course, once you have all of these skills, you can mix them up a little bit. Here's our last question for this video. We're going to determine the shaded area. We've got a circle with a hexagon inside it. Now, we're told that all of the triangles are equilateral. That means that this side equals this side equals this side, which means that all of these sides are the same. Okay, so what am I thinking here? Well, I think I'm going to use the subtractive method, because if I find the area of the whole circle and subtract the hexagon, then I'll know the shaded area. Now, of course, I'm not really sure how to find the area of a hexagon, but I can see that the hexagon is made up of 6 triangles. So I'm going to amend my formula. So now we have circle minus 6 of the triangles. And you can see our multiplicative method creeping in here. So now I just need to find those areas. Now the circle is easy. It's just pi r squared. And I know what the area of a triangle is as well. It's 6 lots of half base times height. And this is where I'm going to run into trouble, because one of these triangles I know is 8 by 8 by 8, which means that I know the base, but I don't know the height. Luckily, I can find it using Pythagoras' theorem. I'm going to do my height of a triangle calculation up here. Now, I can see this triangle, because we only sort of deal with half of this triangle now, because we need this right angle here. So we can say that c squared is equal to a squared plus b squared. In this case, c is the hypotenuse, or always is, 8 squared. A squared, we can let it be this bit here, which is 4, so 4 squared, plus this h, that's going to be h squared there. Alright, so now we have 64 minus 16 equals h squared. 64 minus 16 is 48, so h squared is 48, which means that h is the square root of 48, plus or minus. But of course we reject the negative because it's a length, and so then it's just the positive value here. Alright, so now I have a value of h equals square root 48. Now you can type that into your calculator and get a decimal answer, but there's no need for that. Let's keep it exact, root 48, and now we'll take that h value, put it into our formula here, along with the r value and the b value, and we'll have the area of those shaded shapes. Okay, and I get a final answer here of 34.79 centimeters squared. Now you might be looking at my working here and thinking I've sort of jumped all over the place here. What I would suggest if you were working on this is, if you've got enough forethought, find the height of the triangle first, that's your first step, and then write your area formula. But of course, sometimes maths is a little bit difficult and you jump from one place to another. Just try to make sure that your working is set out correctly. You shouldn't have too much trouble. Alright, that is the area of composite shapes and the additive, subtractive, and multiplicative methods.